Alright, so this is the start of section 6.2. Still dealing with the random variables that we looked at in 6.1, but now we're kind of seeing how can we combine and transform random variables. So we're going to see, we're going to have some formulas that we have that we're going to see how they apply to different scenarios, so why we may need to combine or transform a random variable. So for our formulas here, we're going to let x and y be random variables. Remember, a random variable is something that takes on a numerical outcome. And then a and b are fixed numbers. So what we want to think about is if I'm kind of adding or subtracting random variables, or if I need to take a random variable and multiply it by something or add something to it, that would be like the a and b. So we have some rules here. So these are the formulas. Here are the rules for means. So the first one is mu of a plus bx. So in this situation, I'd be taking my random variable x and I'm multiplying it by some number b, and I'm also adding something to that. That would be the a part. So if I'm adding something that's a, multiplying is b. And this is pretty straightforward then. It's just a plus b times mu x. So you're just taking your mean and multiplying it by b and adding a. So essentially the first part is saying every part of my random variable is being multiplied by b and having a added to it. So to find out what the mean would be, I would just take that mean, multiply it by b, and add a to it. The other situation we want to consider is, what if I have two random variables and I want to add those together? So this is the same as just adding the means together. So if I have two random variables that I'm adding together, I can also just add their means. Okay, we also want to look at rules for variances. Okay, so similar idea to what we did up top. So variance, remember, is standard deviation squared. So in the end, we'll be taking the square root of anything here to find the standard deviation. So if I want the variance of a plus bx, so this is like we're going to that random variable and I'm multiplying it by something and adding something to it. This is equal to b squared times the variance of x. So notice that a doesn't matter. And that has to do with the fact, we've seen some linear transformations before, where when I'm adding something to my variable, or to my distribution, if I'm adding that to everything, really my shape isn't changing at all. My distribution isn't going to be any more or less spread out. It's just going to be in a different location. So if you think about taking a box plot and sliding it to the left or the right, the spread doesn't change at all. So that a doesn't really matter, but the b does. The b would stretch something out or make it shrink. We also want to think about if I'm adding two random variables together. So this is as simple as adding their variances. Now remember, those are variances, not standard deviations. So we're going to have to do some squaring to go back and forth. And then we have another formula when we're subtracting. And this is actually the same as the addition formula. So when we were looking at a mean, we didn't have a formula for subtraction. If we were subtracting, the mean would just be subtracting. It works the same way. For variances, though, that's not the case. It's always adding. Something else to add here. This only applies if x and y are independent. So usually that's something we're given, so something we want to look for. One more note, these 5 formulas here are not on your formula sheet, so those are ones that you'll need to commit to memory, maybe make some flashcards for. Alright, so we're going to go through several examples here to kind of see how those formulas work. The first one is on page 382, number 36. So make sure you're following along here and you've actually read the problem. So if you need to pause and go ahead and do that, please do. So essentially we're given a random variable h that talks about height in feet. And we know that the mean of h is 5.8 feet, and the standard deviation of H is 0.24 feet. And we want to transform these into inches. So they say a random variable J, which is still the same measurement but in inches. So what we have to think about is, well, how would we go from feet to inches? You would have to multiply by 12. So J is equal to 12 times H. If I know somebody's height in feet, that's this one here, I would simply have to multiply it by 12 to find their height in inches. So when I'm finding the mean of J, which is what they're asking for, I'm really finding the mean of 12H. So when I look back at my formulas, I need this first one here. Now I don't have an A because I'm not adding anything, but I do have a B. My B would be 12 because I'm multiplying my variables by 12. So this is just equal to 12 times the mean of H if we follow the formula, or 12 times 5.8, which is just 69.6 inches. We want to do the same thing with the standard deviation. So looking back at my formulas here, I now want this one. So I don't have an A, but I do have a B, which A wouldn't matter here anyways in this formula. So if I want to find the standard deviation of J, let's talk about it in terms of variance first. I would need the variance of 12H, or 12 squared times the variance of H, or 12 squared. I know the standard deviation of H is 0.24, so this would be 0.24 squared, which is 8.2944. So then to get the standard deviation of J, I just need the square root of 8.2944, which is 2.88 inches. So it represents the same population, we're just transforming from feet to inches. Let's look at another example. This one is on page 383, number 44. So go ahead and turn to that and read it. So we're given a distribution here where we have our random variable x, which is the profit. And they give us the mean of x is 3. The standard deviation of x is 2.52. So this is just the given information that we're going to use here. So what we have to look at is, what is our new random variable going to be? Well, they tell us our new random variable y is equal to 0.9x minus 0.2. So what this has to do with is that company has to give 10% to somewhere. Oh, their lender fee is $200,000 plus 10%. So the 0.2 is subtracting off the $200,000 because this is all in terms of millions. And then if they have to give up 10%, they're only getting 90%, which is where the 0.9 comes from. So I want to find the mean and the standard deviation here. So the mean of y, you can think about that as the mean of 0.9x minus 0.2. So here my A would be negative 0.2, my B would be 0.9. So this is just simply 0.9 times the mean of x minus 0.2. So you're just substituting in that mean of x, which is 3. So we get 2.5, and that's technically million. Okay. For the standard deviation, now in the last one we did it in terms of variance first. If you're at the point where you can just say, I know I'm going to have to take the square root of n, so I might as well start with that, that's fine. So before we do that though, the standard deviation of x is going to be the standard deviation of 0.9x minus 0.2. which is the square root, and following the formula is just b squared, so 0.9 squared times the standard deviation squared, so 2.52 squared, which ends up being 2.268, excuse me, million. So really this is just practice following those formulas. So at this point we're going to have you guys try one. So this is a CYU on page 367, numbers 1 and 2. So pause the video, go ahead and try those, come back and see how you did them. So let's see how you did here. Alright, so you were given a random variable where you're talking about the number of cars sold on Fridays. They gave you the mean of 1.1, standard deviation of 0.943. And they say the manager receives a $500 bonus. So Y is the bonus he received. So you should have had that Y is equal to 500 times however many cars are sold if he's getting $500 per car. So then when you find the mean of Y, it would have just been 500 times the mean of X, or 500 times, they say the mean is 1.1, which is $550. All right, when you do the standard deviation then also for number 1, the standard deviation of Y is going to be equal to the square root of, I know my B is 500, so 500 squared times that standard deviation of X, which was 0.943 squared, which makes the final standard deviation 471.5. Let's see how you did on number 2 then. So number 2 is still talking about the same situation, but instead of just getting that bonus, he's going to also spend $75 to get people there. So his total bonus is going to be what he received minus the $75. So the bonus he got minus the $75 because he wants to subtract off what he paid for in donuts and coffee. So when I do the mean of T, this is going to be just the mean of Y minus $75. So 550 minus 75, so just 475. Now when you think about doing the standard deviation though, if we look back at those formulas, we're doing this one here again. So I don't have a B here because I'm not multiplying. I've already done that part. Here I'm just subtracting the 75. So think about A being a negative 75. So that does not affect the standard deviation at all. We've already done the multiplying part. Addition and subtracting don't affect standard deviation. So the standard deviation of T is still just $471.50. All right, so we've done kind of the first 2 formulas here where we have, or in each section where we have A and B. We want to look at some now where we're combining random variables, so like the X plus Y situation. So let's think about this example. We have a college student getting ready for their final exams. X is equal to the number of final exams the student has to take. Y is equal to the number of final papers they have to write. So some classes do one or the other. Some classes you may have to do both in. And we are given that X and Y are independent. Okay, we're also given then that the mean of X, so the mean number of final exams for students is 1.95. And the standard deviation for the number of final exams is 0.865. We're also given the mean for final number of papers is 1.3. And that the standard deviation for final number of papers is 0.843.